All right, so the key with this coconut problem is to realize that we have a horizontal unbalanced force from the wind and a vertical unbalanced force from the force of gravity. I've gone ahead and drawn a good picture to show those forces and labeled how big they are. 4 newtons to the left from the force of the wind and 12 newtons down from the force of gravity. And throughout this problem, in my calculations, I'll define positive and to the left as down. And from the problem, I know the coconut is initially at rest, and both of these initial velocities are both 0, but I'm going to go ahead and make a difference between horizontal velocities and vertical velocities and the accelerations. I know vertically, we've got 9 meters of displacement that the coconut's going to have as it goes from its initial point up here down to its final point somewhere down here. That's going to be down to the left of where the coconut currently is. But everything else I don't know, but those can totally be calculated. And I can use any of my equations of motion to figure out that the velocity of this coconut right before it hits the ground will be positive 13.4 meters per second. That's that vertical velocity right before it hits the ground. And the time will be 1.34 seconds. That's how much time it'll take. That'll also be the horizontal time that the coconut is traveling for. But I still don't have enough knowns over here to be able to figure anything out. But I can figure out what the acceleration horizontally of the coconut is using Newton's second law. That the coconut is being pushed by a 4 Newton force to the left, and it has a mass of 1.2 kilograms, so the acceleration will be 3.33 meters per second to the left. A lot of times when something's flying through the air, we don't have this horizontal force, so we usually have a constant horizontal velocity, but in this case we do, so we have to pay attention to that. And then we can do some more calculations to figure out what this final velocity will be horizontally, and that's 4.46 meters per second right before the coconut hits the ground. And then over here, I can draw a picture of that coconut right before it hits the ground, and its vertical final velocity of 13.4 meters per second, and the velocity it has right before it hits the ground horizontally of 4.46 meters per second. And then combining those, I can use Pythagorean theorem to get a velocity of 14.1 meters per second. And then with a little bit of trig, I can figure out that this angle is 251.6 degrees, which makes a ton of sense because it's going to be a whole lot down and just a little bit to the left because I have much more force down than I have to the left. But that will be the motion of this coconut right before we hit the ground.